Okay, this is 1.9 graphing calculators. We're going to talk about solving equations and solving inequalities graphically. So obviously all this will be on the graphing calculator portion. A lot of what you do will be on the non-graphing calculator portion from section 8 and 10. But most of you know how to use your graphing calculator. This is the window, so some of your homework problems are going to say, hey, look at it in a certain window, and this is for your x, and the second one's for your y. So example 1 says to choose an appropriate viewing rectangle. If you'll graph this equation on your graphing calculator, most of you know we can zoom 6, which is the standard, so negative 10 to 10, negative 10 to 10, and that's fine. That's an appropriate window. I can see the vertex and I can see the shape. We can also zoom in, and I can kind of scroll up to where I want to zoom in and zoom in a little bit there. I can see a little bit closer. You can zoom out the same way, and you can also zoom fit, which is your 0, and that will change it to see more of the whole picture. Sometimes that's a good first place to go to. Sometimes it doesn't work. Sometimes you'll just have to adjust your window, and you can do that by going to window, and then you have your x min, x max, y min, y max. Okay, example 2 says graph the equations, and it gives you 2 equations together in the viewing window, and then this is your viewing window where this is your x and this is your y. Okay, so I put them both in my y equals, and that's what yours should look like. Remember, at any point you can pause the video if you need to make your screen match up with mine, and of course you can always rewind. And then my window C, the x min, x max, and then y min, y max. Kept my scales 1. It says do the graphs intersect in this viewing window, and we look at it, and yeah, they sure do appear to. But if you'll actually, so yes, the answer here is yes, they do, but that's why it's important to find an appropriate window, because if we zoom in, they still look like they intersect. Zoom in one more time. And they don't. So it's important that you check that out and zoom in as far as possible and get an appropriate viewing rectangle, because sometimes the graph can be deceiving. Example 3 says graph a circle. In here I can only type y equals. And so I'm going to have to solve this equation for y. When I do that, if I were to have you do this, most of you would probably do something like this. And then I'd say, what do you do when you take the square, when I need to solve for y? You'd say take the square root. And we would probably get something like this. And that's great. And when we plug that in, this is what we get. So you can see my y equals, and you can see my graph. We know this should be a circle because we already talked about that, centered at the origin with a radius of 1. But you can only see half of the circle, and that's because when you take the square root, you get a plus or minus. So I should type in this and the negative version into my y equals separately. The positive got the top, the negative is going to get the bottom. Now I graph both of them, and you can see now that it kind of looks like a whole circle. It's a little distorted. If you zoom in, it'll look a little bit better. This honestly isn't the best way to graph a circle, and we'll talk more about the polar coordinates I told you about in chapter 5. You can see that there's a little gap here, and that's really just because the calculator graphics aren't that great. Okay, apologize for the video being very choppy. I'm just trying to save you from having to watch me type it all in. You know how to solve equation algebraically, and then obviously graphically is with your calculator. So make sure you follow the instructions and do which one it says. If you have the option, you can do either. But you should know the downside to solving anything graphically is that it's not as accurate. That's a huge downside. You saw when it looked like they intersected and they really didn't. If we were to solve that algebraically, we could know without a doubt they don't intersect. So be really careful. Honestly, it's best to check your work by graphing, but obviously always solve by algebra or using your pre-calc. Okay, solving a quadratic equation algebraically and graphically. I'm going to quickly work it out for you algebraically, and then we'll plug it in our calculator and see if that matches. Okay, if you try to work A, it won't solve by factoring, so I worked out the quadratic formula. I'm not explaining all my work. You should know how to do this by this point. If you have any questions, let me know. I get 2 plus or minus the square root of 2, which is approximately 3.41 or 0.59. And then if I go to type that in the calculator, put it in my y equals, I'm just going to do a normal standard zoom. And so I can see it crosses about there and there. To find where those points are on your calculator, we're going to go to second, trace, because I want that calc. And I want to calculate the zero. Remember the solutions, the x-intercept, the zero, the roots, all of those are the same thing. So I'm going to trace my zero. It says left bound, so I want somewhere to the left of it. That's good. I'm trying to find the zero right here. I'm to the left of it. Now right bound, so I'm going to go to the right of that zero. So my zero was right in there. I'm to the right of it. I press enter again. Then it says yes. And I say yes because that's what I want it to do. So I press enter a third time, and it tells me it's 0.5857. Very accurate. Not completely, but very close to being what we had. It wasn't as accurate as this, of course, but it did hit that. So there was one of them, and then we can do the same thing and go to second trace, which is calc. Calculate the zero, go to the left bound, but this time I'm wanting this zero, so the left is going to be somewhere over here and the right's going to be somewhere. So I'm left bound, and it really doesn't matter, but it's kind of best if you try to get close to it. And then right bound, I'm going to go slightly above, and I'm going to press enter a third time to guess, 3.41, and so it got my other one as well. So this is great when you're wanting a rounded zero, but obviously it won't give you the actual radical. Now I want you to pause, and I want you to work B and C on your own, both algebraically and graphically on your notes, and then check with me to see if you get the right answer. Okay, our example B, it does factor. It's a perfect square, so x minus 2 squared. And if I solve, that's x equals 2, which is a repeated root. And I graphed it on a standard zoom, and you can see it does look like it hits that, and we can actually make sure there's only one zero here. So I'm going to go to the left of it, and then the right is back up here. And I get 1.99999. We know that the zero is 2 here, so you can see how it's a little bit inaccurate. It gives me a 3 at the end. Now, pause, work C. Okay, so I wrote this one out. It doesn't factor. I did quadratic formula. We simplify. We get 2 plus or minus 2i. It's imaginary. So we would expect to see that this doesn't graph. And so here again, this is one that you can type this in your calculator, and we're going to do that, and we're going to see what happens. But it's obviously not going to give me the answers in the imaginary, and so this is why algebra is much better, but it's good to check. We can see it doesn't cross the x-axis, so it has 2 solutions, but they're imaginary. Before you would call this prime because it doesn't factor. And so here the graphing calculator helps you. It tells you it has 2 imaginary solutions, but it doesn't tell you what they are like the algebra. Okay, example 5, solve the equation algebraically and graphically. Pause, solve it algebraically, and then we'll talk about solving it graphically. Okay, sorry for any extra noise. I'm in the car, which also makes my handwriting worse than normal. But I solved for x, and I got 25 over 11, which is 2.27 repeating. Now, the easiest way to solve for x graphing here is to graph this and to graph this separately. And then when we look at them, the intersection is where the x is. So the intersection is where what these two have in common. And here you can see, oh, it looks like it's maybe about 2 with our x. But same place we went to calculate our zero, we can trace and calculate the intersection. It's going to ask for the first curve, so you want to get as close to this intersection as you can. And then it's going to jump to the other line, and you might not even be able to tell a difference. But again, you need to get as close to that intersection as you can. Hit enter again. Yes, we want to guess. We hit enter last time, and it says the intersection is 2.272727, and then negative 1.81. We only solved for the x, but this would be the y value at the x. And so again, you can see it's pretty accurate, but obviously our 25/11 is more accurate. Okay, here's a problem where it does help us to solve graphically. So we have this equation, and you wouldn't really know how to solve this because there really isn't a good way. It asks for specific intervals, so there might be more x's, but we only need the ones from 1 to 6. So what you can do is you can do what we did before and put this in your x-axis and your y equals and this in your y equals and find their intersection. It's really going to be easiest, probably, and you could do this one on the previous one as well, is just to move that over so it equals 0 and plug it into our y equals. And so that's what I did here. You can see the whole strand of it, and then I'm going to graph it, and you can see it kind of looks like a cubic function. It has that hump, of course, that changes it a little bit. And you can see it probably costs us there, but that's around 0, which isn't in our interval. Around here, maybe 2 and maybe 4. So what I'm going to do is I'm going to zoom in a little bit just so I can see better what's going on. And a lot of times that helps the calculator when you're trying to find intersections to zoom in. So again, we don't need this one because we're only interested on the interval 1 to 6. And I'm going to first try to find this one by calculating the 0 again. So I'm going to go left of it, right of it, and enter. And it tells me 2.17. That rounds up to 2.18. And that's the best I can get on that. Algebra won't help me, at least with what we know here. And so that is a good answer. That's the best we can do. We're going to also go in and the same way find this one. Again, you didn't have to zoom in, but a lot of times it'll help it be a little bit more accurate. It might be way out in the decimals that you're not even looking at, but it does help some, and it helps you get a clearer picture as well. And so for the other intercept, it says 3.72, and that's still in our interval. So that's relevant as well. And so we have two different answers, and we found those graphically. Okay, I'll be honest, this is kind of an ugly problem, but don't get overwhelmed in it. It says two light sources are 10 meters apart. One is 3 times as intense as the other. The light intensity L in lux is at the point x meters from the weaker sources given by, and it gives you the equation. It's ugly. That's fine. At least you don't have to find it. It gives you a picture. It doesn't really help. All that matters is this equation, and I want to find at 4 lux. Now, that is going to be L, which is like my y, right? It's not my x. And so I'm going to graph this. Now, be careful when you graph it. I'm going to type it in like this, but I'm going to put big parentheses around my second equation so it adds the whole thing. Okay, so that's how I type it in. And then I'm going to graph. And it looks something like this. And what I want to find is where it is 4. So I'm wanting the y value, right? L is my y. 1, 2, 3, 4. I'm wanting this around here. And I can look at my table, and if you don't know how to do that, I'm going to go to second graph, which is the table. And that's really helpful because it tells me all my points. But I want to know where my y is 4, and it just skips right over that. So this isn't helpful, but we can use one of the tools. And I know we've had several different graphing tools, but hopefully you can remember them because you already knew most of them. Where if I want to know where y is 4, I can graph y equals 4, and I need that intersection because that is where y equals 4 on my graph. So I'm going to do the same thing we did a second ago and find the intersection of these two lines. You see my little spider coming down. First curve, second curve, and it's going to guess y is 4 approximately when x is 1.67. And so it says find the points at which light intensity is 4. One is 1.67. And then if we go back, we have another one here. We're not going to deal with a negative, and then we're going to have another one here. Okay, I just paused it and did it on my own. I did second intersection, first curve, enter, second curve, enter, and then enter. And it told me it's 4, also about 7.19. So that's our other option. I'm sorry, we have 2 problems left, and I only have like 50 seconds left. So I'm going to stop this, and then you can pull the second video, and it won't be near as long. And we'll finish out these last 2 problems, and it is important that I want you to know about Allen Turing.